Hello, Science 20s. Our lesson today is going to be on corrosion. If we take a look, corrosion is an electrochemical process in which the metals react with substances in the environment. Really, what we're looking for is corrosion is the oxidation of a metal. Now, we don't have to look at iron. Iron actually is corrosion, but iron actually has a special word for its corrosion. We call that rusting. However, lots of metals can actually corrode. The reason we talk about iron a lot is because we overuse the word rusting, but the other thing is iron is really unique compared to most metals. Iron is interesting because when it corrodes, it actually doesn't get a nice protective layer like some things do, like silver or zinc. Iron actually, as it corrodes, its layer actually peels back, and then more iron is exposed. And so it corrodes, and these pieces of iron then flake off. And so you leave holes in things, pieces break off or snap off, and it causes a lot of structural and problems, but with that, economic problems that cities have to handle. Well, if we think of iron or aluminum and we expose it to the environment, electrons are being pulled away from the metal atoms. So we call that oxidation. So if we look at these two half reactions, iron going through rusting or aluminum going through oxidation, we can see that the electrons are leaving, right? Losing electrons. Is oxidation. So they are leaving. And what this means is because remember, oxidation and reducing agents go hand in hand, they go together. So the metal in this case is acting like a reducing agent. So the iron is a reducing agent, the aluminum is acting like a reducing agent because these solid metals are getting oxidized. Now, if we look at the corrosion of different metals, we will see that this corrosion is very dependent on the potential of the oxidation. And I always like to say it as how noble the metal is. So you've heard the word noble before. Noble, when we were talking about periodic table, like the noble gases, they were the unreactive ones. Well, again, when we look at this table, we're going to find that the more noble the metal, gold is very noble, right? Kings and queens have lots of gold. They're noble. Silver is noble. That means they are weak reducing agents. Because they are so noble, they will not oxidize. Whereas the nobility goes down and we get less noble, like aluminum is less noble and iron is less noble, that means they are going to be stronger reducing agents. They will more strongly want to oxidize. They are going to corrode more easily. So let's take a look at this on the table. So if I was to come here and grab my pen, right? These are strongest oxidizing agents. These are my strongest reducing agents. Well, if we look on my table for nobility, up here is going to be the most noble of in all the land. So when we are kind of mixing these, and oxygen tends to fall around here on our chart somewhere, right? There's a lot of non-spontaneous reactions. Oxygen and water that we need for rusting, it's not going to react with gold or silver because these guys are uphills, right? These are non-spontaneous reactions. Where, however, oxygen and water and those reactions, if we threw them on the table somewhere, they will react with iron for sure. They will react with aluminum for sure because these are spontaneous reactions. So if I was to go back a slide again, aluminum and iron are strong reducing agents, right? They're closer to the bottom right hand corner. So they will oxidize, they will corrode. That is the key. Now, my question to you then is if we go to build a fence, do we build it out of iron poles or do we build it out of aluminum poles? Now, if we were to look at our table, I think right away most of us would say, well, Mr. Kemp, for sure we build it out of iron poles because here's aluminum, and aluminum is going to react before iron is. right? Because it's lower down. This is a stronger reducing agent. So ideally, it will react with aluminum first. So this guy's going to have a more serious reaction. We probably would want to build it out of iron because aluminum will have a reaction. However, I want you to think about one of the other properties we talked about today when we were looking at iron. And that is, right, when iron reacts, unlike the other metals that might just get a protective coating put on top, so it's almost like a line of defense, right? Something as like a little barrier, like maybe a coat of arms around it, so that now it's got a little protection. In iron, it doesn't work that way. When iron starts to rust a little bit, it falls off and exposes more, and then more pieces fall off. So when you read your way through this, ideally, the answer we want is we really have to go, no, totally need to build it out of aluminum posts because aluminum posts, when they corrode, they actually maybe even get a little bit stronger because they get another protective barrier surrounding them to stop the water and the acid from acid rain and the oxygen from making contact with those posts. Now, here is probably the most important drawing I could pull out for today. And the drawing that I'm looking at here is this is what happens on an iron surface outside. So I have a piece of metal iron. You'll notice there's a water droplet on here. Now, there's a few things that are critical for us to talk about in order for there to be rust. One, you have iron or metal, you have oxygen, and you have water. And so you'll see we have a water droplet here. This water droplet is rather important in this example because this water droplet, you'll see, is it has ions in it. And it's those ions that kind of turn this almost mini voltaic cell or battery. And that's what we've made here, right? We have some electrodes, we have some electrolyte. We've made a battery here that's going to cause this to rust. So it forms ions when water hits because we have iron ions, we have hydroxide ions that are coming through. Because ideally, this piece of metal is going to act as both the anode and the cathode. And so it starts eating away, or where the iron is losing electrons at the anode, right? Because anode is where oxidation occurs. Oxidation is where we lose electrons, Leo. And so it's one of those where these electrons are leaving, they're leaving the iron section, and you'll notice they're coming over here to where the water and the iron is making contact, and they are gaining these electrons that are leaving the anode are getting gained at the cathode by the oxygen, by the water that's naturally in the environment, right? Metal automatically is going to make contact with oxygen out there in the out there in the air, or water when it rains, or in some areas where you are, maybe on the East Coast where it's a little bit more moist or there's a lot more rain, that water is just more naturally there. So it's one of those where these electrons automatically move. Well, when you add together the two products that are made here, these two products, these guys are what forms rust. And that is that orange color that's forming right here in between these, because the electrons are coming over here from anode to cathode, following, of course, alphabetically. But more importantly than that, these anions are then going to be moving back towards the anode, and these cations are going to be moving over towards the cathode, and we're going to complete this circle and complete this battery, and we're going to have a full cell going on here, and that's what is going to cause the rusting. And so we're going to have all this rusting that occurs in here, this reddish stuff, and pieces are going to break off, and it's going to rust some more, and pieces are going to break off. Well, the big question then comes to, how do we stop this rusting? And there are three ways to stop rusting. Easiest way, most simple, is barrier method. Put something up so that iron is not in contact with oxygen and water. So We can paint surfaces. We can put wax on surfaces. We can oil surfaces. We can put plastic coatings on things. So I chose this example because it's something I think we all recognize. Here's a steel beam. Now, a steel beam is made up of more than just iron, but a majority of it's iron. It's usually iron and carbon and manganese. But this steel beam, rather than let it rust when water comes in contact, what they do tend to do is they paint these I-beams or steel beams a color. And in our example, they painted it red. This way, oxygen can't get in contact with the iron. Water can't get in contact with the iron. Now, this is actually a problem. When we do this same thing on a car, but the moment we get a little bit of a chip, right? A little bit of paint's exposed because it's fallen off. Now water and oxygen can get under there and make contact with the iron. And this is why it's really important that when you have a new car, and all new cars, they come with a little thing. It almost kind of looks like nail polish, and it's paint for your car. And you can, when you get a little chip, you just kind of paint over it so the water and the oxygen can't make contact with the iron body, because if it makes contact, rusting is going to begin. So barrier method, putting a barrier between the iron and the other criterias for corrosion. The second way we can stop corrosion is galvanization. Galvanizing is when I take my metal, my iron, my steel, and I put a coating of zinc around it. Now, the zinc does two things. One, it provides a barrier, right? So if the water and the oxygen can't get to the iron, it can't rust. But the other big thing it does is zinc does not, when it starts to corrode, break off. Zinc actually just gets dull and it puts a nice coating around it, almost like a little, it hugs it, the iron, and puts like a little barrier there. If you've ever heard of galvanized nails, those are the nails or screws they use when they put on, let's say, your shingles on your roof of your house, or you put up a fence, right? Because they're going to come in contact with rain and sleet and snow and all these conditions, and people overspraying their yards and hitting their fence with their underground sprinklers. And you don't want your nails to all rust and all of a sudden all your screws and nails rust and all your boards fall off your fence. So they take the iron nail for strength inside and they coat all of these nails and screws with this zinc. The other reason that zinc is so good is, let's look here for a second. Well, here's iron on your list. Oh, so here is iron on your list. Okay, here's zinc. Zinc is a stronger reducing agent, which means zinc is going to go through oxidation before iron is. So when oxygen and water comes in contact, it's going to seek out zinc first before the iron. So it's going to have a reaction. Well, that reaction is interesting because what that reaction is going to do is that reaction is going to put a little bit of a barrier on this thing. And right, this is going to, on my nail, make it all cloudy and dull, but this is going to put an extra protective coating so that the iron can't be reached. Now, this extra protective coating actually has another name, and this other name is called a sacrificial anode. It is exactly what it sounds. We are going to sacrifice one metal for another metal. So in our example of the nails, we will sacrifice zinc because zinc is a stronger reducing agent. It will sacrifice itself. So this is the exact example that they do on a giant ocean liner. They put bars of zinc on the rudder and on the bottom of the hull so that when the salt water, right, it's more acidic, it's going to go react quicker. When the oxygen comes in contact and it starts rusting, it actually sacrifices these little pieces of zinc first, and these guys get eaten away before the iron of the ship is actually touched, because it takes the path of least resistance. So on this thing again, you've seen this before. It would rather go to the zinc here than the iron, even though it's not completely covered. They put these blocks onto the bottom of these ships because this will get eaten away first, which means zinc is gonna go through oxidation first because it's my strongest reducing agent. Now, when you think about this, then, what else could we use besides zinc? Anything below zinc is going to be stronger than iron. So they use aluminum blocks and they use magnesium blocks all the time. So, what I want to do is go back to our little picture for a second, and you can see you already know oxidation occurs at the anode. Anode is eaten away. So, if I find something else that will be an anode before zinc, then that will be the metal eaten away. And by default, the zinc ion will then be my cathode, and it will actually be just safe there, and we are protecting it. We are sacrificing another metal, zinc or aluminum, for iron. We are going to save iron, and we're going to throw zinc under the bus. By the way, this you do this all the time at your house in a hot water tank. Inside the tank, there's actually a sacrificial anode that gets eaten away. You'll know when that sacrificial anode is gone and it's no longer there, and so your tank is getting eaten from the inside out, because you'll notice that your water, when you turn on hot water, will be a slightly more brownish color, and that totally tells you it's time to open up the top, pull it out, and you can go to Home Depot and get another anode for inside there and replace it in your hot water tank.